Hello, good evening. Today I'm going to show you some math. Basically, it's about linear algebra. In my university, I'm required to learn a course called linear algebra, coded MA1101R. So this is an introductory course that is a requirement for all engineering or maybe computer science or math and statistics major students. So since I'm a student who major in economics, it's still a requirement for some of the economics students though, so I was one of them. And today I'm going to show you some proofs. Again, it's another proof about a particular concept called rank. So I'm going to write on my paper, so it will be easy for me for my reference. Okay. So we first write rank. And this is our topic. So now, I want to prove that if A is I times n matrix, prove every vector in null space of A, I believe you know what null space is orthogonal to every vector in row space of A. That's very interesting. If you don't know this one, after you find out how this works, you will be astonished. I was astonished at that time. How can these two unrelated, these two concepts become, orthogonal? How does orthogonality involved here? Well, if you think about it, the null space is all the solutions of V to AV equals 0, right? And that might give you some hint. So let me pause it for a while. Okay. I also need to look into the answer booklet and to explain the things to you. So bear with me for a moment. Okay. So what we would like to do is that. So first of all, we let so I will not use this notation. That A1, A2 to AM be the row vectors of this matrix A, so that row space of A is equal to span A1, A2 until AM. Make sense? Okay, next. Suppose there is some X which is in null space. This will imply, as I said before, AX is 0. And we also have something like AI dot X is 0 for I is 1, 2 until n. Do you know why is that? Because AI is a row of A. For example, AI could be 1, 2, 3. Is that a row? No. So for example, AI can be 1, 1, 2. So this is a row. Okay. Then X could be, well, X1, X2, X3. You know? Let's suppose this is a matrix. This is a vector. And they will give you 0, 0, 0. Is that correct? So if AX is 0, then the first entry here should be 0. But the first entry is just the first row times X, the dot product of first row and X, or the multiplication of 1, X1, 1, X2, 2, X3 is 0. So by this we mean that all rows of A times a vector would be a 0. So that explains this already. Okay. So now I'm going to continue. So now we are going to look at row space of A. So if R is in the row space of A, then R should be in the form C1A1 plus C2A2 plus CM Why we get this result? Because the row space is all the rows the A can span. The row space is the span of the rows of A, right? For example, we have 1, 1, 2, 2, 4, 6, 3, maybe 3, 3, 3. The row space is span of all the rows. So it's a linear combination of all the rows here. But this is also the same for column space as well, if you look at the other direction. But for now, let's look at the row space. Okay, then we do a dot product. Everything in the row space of A times this vector, which is in the null space of A. They are arbitrary vector that satisfy the condition in the question, but we don't know the exact number of this, but we can compute. So it will be C1A1 plus CMAM times X, because when we put X here, here, and here, you will get 0 in every entry, right? So I'll give you a 0. A dot product is 0 implies that the vectors R and X are orthogonal to each other. So now you can see that row space of A is always orthogonal to the null space of A. Of course, we have the theorem as well that the column space of A plus the null space of A is everything. That might give you some new refreshing moments to think about rank. Hopefully this works. So that is one proof. Now let's look at the other proof. So proof rank of AB is equal to the rank of B. This may sound a little confusing at the beginning. You may wonder why I pre-multiply A to B. I have two matrices together. How come this rank become even smaller than the original matrix B? It should be bigger, right? We have two McDonald's Big Mac burgers, then we have 3 multiples of the burgers. We'll get 6 hamburgers. So, but this is not like buying McDonald's Big Mac. So it's math. Okay, so we're now going to prove it. So how are we gonna do it? Well, as you all know, if a set of columns of AB is linearly independent, then the corresponding columns of B are linearly independent as well. Right? So it follows that the maximum number of K of linearly independent columns of AB is not more than the maximum number of linearly independent columns of B. So in other words, rank AB is less than or equal to rank B. Does that make you clear? So I'm going to write something down. So as I mentioned, if BI is the ith column of B, no, this is a column, then ABI is the ith column of AB. Then this is going to be more like a proof by a lot of words. Then ABI is the ith columns of AB. So if all the columns of B are linearly independent, then there are scalars Ci to C1, C2 to Cn such that okay, I will write down for you. Then CIB1, C1b1 plus C2b2 plus dot 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 Cn will be 0. Yeah. So if it is linearly independent, Ci, C1, C2, Cn should all be 0. This is a working definition my professor told me. Okay? So let's look at AB. So we multiply A to this equation. Can we? Yes, we can. So it's C1AB1 times C2AB2 and plus all of them until CNABN is 0. And C1, C2, Cn is still 0. So I need to put some words here such that C1 is equal to, Cn is 0. So because C1 is still equal to Cn is 0, so AB I is also linearly independent. Okay, so it's still linearly independent. The columns of AB is linearly independent, right? Then we can make some conclusion, some sort of conclusion here. So the maximum number k of so that k be the rank AB. It should be less than the rank of B, because the rank is all about independent columns, right? And since the maximum number you can get is when columns of B are linearly independent, so the maximum number you can get is equal, the rank AB is equal to the rank B. But if it's not linearly independent, then it will be less than rank B. Okay, so that is a proof. We're going to remember, and for now, have a break and refresh your mind at the other day and continually support my videos. Thank you guys. Have a good night.